Whenever you need to animate something in a game, you have two options: draw it frame by frame or partition it and move each part separately. To do so, you need to rig a character or assign its body parts to an abstract skeleton. If you have many differently shaped 3D models to rig, this process can take very long time. What if you could do it automatically? Hi, I'm Smok. Welcome to my channel where I show how I code things and talk about career in tech. Today I want to return to a project I've started some time ago, a game called Lizard. I've published a couple of deep dives into some early aspects of the game, but then I went silent. It's not because I lost interest, but actually I have stumbled on a more intensive part I wanted to get done before showing it to you guys. As I have said, I'm interested in making the game as procedural and as full of uniqueness as possible. Huge part of experience is, of course, the character of a player and other characters filling the game world. Creating thousands of creatures by hand and animating them is not really possible to achieve by a single person, surely when they do other things like recording YouTube videos. So I thought it would be cool if my game engine could step up and save me some work. Even cooler if anyone could make a character that could be used in this game. I wrote quite a lot of code to achieve that, and I will show you how it works. But first, let's explain the general idea. I really enjoy simplicity in games, and when it comes to graphics, pixel art is my style of choice. However, since I wanted a 3D world, we need 3D graphics. So 3D version of a pixel is called voxel and represents color data in a 3D grid. Voxels aren't new, and there are a lot of tools available to create voxel graphics. The one I like the most is called MagicaVoxel, and it's available for free. To be fair, ultimately, I want most of the creatures in this world to be generated from scratch by some code, but for now, I just need something to start with. So I'll open MagicaVoxel and I'll design this character I'll be using. If you had freedom to play whoever you want, who would you choose? Leave a comment, or better yet, download MagicaVoxel and come up with a creature yourself. Maybe I'll add it. Alright, so here is the model I will put into my game. You might not know this, but MagicaVoxel's format is available openly and you can parse it. It contains many things, but most importantly, every voxel is represented by position, X, Y, and Z, and color ID. I've read it into memory of my game and produced a static model. If you're curious how I've done that, there is another video talking about this subject. Now here comes the tricky part: how to make this thing move. Computers don't understand the world like we do, so just telling them move that hand isn't going to work. What you see here is actually a collection of colorful triangles that creates an illusion of a character. And it's quite tricky to make those behave like a real person. So here are 3 obstacles that I had to overcome. 1. How to determine where exactly the character has arms, legs, head, torso, and more importantly, at which points they are attached to each other. Second thing is how to translate that information into bones and joints, bendy and not so bendy things. And finally, how to add this information back to the generated model in a way that 3D engine can understand and animate. I'm not gonna lie, these steps were quite hard to get right, and I've spent much more time than I originally planned. I considered giving up much more often than I'd like to admit. First step, which is dividing our guy into sections, may seem easy, but really it is not. What we are starting with is just a 3D array of points and some color information. We don't care for colors that much right now, but we can surely figure out which points are close to each other and which aren't. I had multiple ideas how to properly do it. I could try and find where the model has right angles, or maybe try to find surfaces and detect the alignment of voxel clusters this way. But all that didn't quite fit in my mental model. So I have searched the internet far and wide to figure out a good solution, and I found it. voxel thinning algorithms. There are a few of them invented over the years by mathematicians and computer scientists, and quite often they are hard to understand and recreate in the code. After extensive search, I found one that is going to work for me: open thinning. It's fast, relatively simple, and comes with a C++ implementation. Even better. So I took the C++ code and rewrote it in C#, and it just worked. Look at this, almost like a real skeleton. It must mean that we are getting close. Then I'll check how those skeleton voxels are connected, and I will end up with a graph that represents all of the axes of the model. These aren't bones yet. I need to somehow merge these 1 unit long connections between nodes into something that can approximate the bone. First step is easy, just merge everything that is in a straight line. Then check which neighboring joints have angle close enough that they could be merged to form a simpler, less complex skeleton. Remember that we need to do this to be able to animate it later. All that is left is to do removal of some overlapping bones. So we solved the second problem. We know where bendy joints and not so bendy bones are. However, this algorithm still cannot tell us which of these bones is an arm, a leg, but at least we know exactly where they start and end. Since we have a very rough skeleton, we could probably write some simple rules to come up with proper matching. But now let's focus on the third part of the problem instead: how to map bones to actual voxels of the model. Let's start by saying exactly what bones are in this scenario. They are a relation between 2 points in space. So I'll use the A* algorithm to traverse the voxel skeleton from one point to another to get a list of voxels that are the bone. To assign all voxels to bones, we'll just select all of the neighbors of those bone voxels, and we'll make it part of the same list over and over until we assign all remaining voxels. Let's see what we are getting here. I've assigned a random color to the bone and marked all voxels that belong to this bone with that color. Hey, we can move the parts of the model independently. This is great. Obviously, right now we have few issues. The biggest one is that we don't have enough resolution where joints are. This means that Unity Animator doesn't really bend the model on joints. It just uses the points that are the closest to the joint to simulate bending. So basically we'll need to add more detail where one bone meets another. Some of that voxels may actually belong to more than one bone. Let's mark those in black. Now we need to actually produce more triangles in those areas. Let's create a separate face for every black voxel. With more points to bend on, we can think how to blend the effect of bending the joint. We can see some overlap, but it's not big enough. So I will average the bone ownership across the neighboring voxels in a way similar to the blur effect in Photoshop. You can see things are still breaking. I had a bug in the code that was applying bone relations after optimizing the model, so watch out for that if you ever do this kind of thing. I tried to figure out my mistake over multiple iterations, and eventually I've decided to improve my understanding of the system and changed how I visualize bone effects on voxels. Just assigning the voxel to the bone was not enough. Multiple bones could be in effect. So I wrote better debugging tool and got it solved. Here is the end result. As you can see, this works on multiple models, not only humanoids. This import tool is still far from perfect. I'm adding too many points on joints. I could easily get away with less than a quarter of this. Other thing that is missing is the actual labeling. Which bone is which? Set of these labels is called avatar and is used by animation systems to abstract the movement away from the model. So multiple unrelated characters could share the same animation files. This, however, has to wait for another time. Subscribe!